Welcome to another episode of Better Performance. In this episode, we are going to discuss about the design pattern and how design patterns are going to affect your application. In the software application world, design patterns are very important. These design patterns decides that how your application is being coded, how it has been designed for different aspects like manageability, scalability, database, everything. So let us see that how design patterns are going to work. All the design patterns had certain goals. Main goals is that you need to know that whether these patterns are good for your application. Also, this pattern language enables you to use microservices architecturally successful. And these two things are very important. Let us understand that what all the different dimensions where these patterns are going to help us. So when we say that goal of design pattern, always we go into the NFRs and FRs. So in NFR, we have that performance, scalability, resilience and self-healing, better operation, evolution of design and adaptable with changes. And it should on top of that have a functional requirement of serve business needs as well. So all these things are required over here. There are multiple design patterns. I will have a list that this design pattern. So there are various design patterns like application architecture pattern, decomposed by business capability pattern, refactoring of microservices pattern, data management patterns, communication style patterns, transaction messaging pattern, observability patterns, reliability patterns, security patterns. All those patterns are there, and on these patterns we pick and choose that which pattern is good fit for our application. So this slide I'm going to use in many of the future sessions where we will discuss that what all patterns and what are the benefits and pros and cons of those. In this session we are going to discuss under the communication patterns, and this communication pattern is very important for our application. Generally, there are two types of communications. One is that inter-service communication, another is the external communication. Inter-service communication is basically communication between the different microservices. Either you have that point-to-point microservice connections or you have that mesh architecture. In all the architecture, this inter-service communication happens by two methods. One is that sync communication or async communication. If it is a sync communication, we use generally HTTP protocols, TCP protocols, and binary protocols. In async communication, we give this information to a database or a messaging protocols. They are carrying these messages and other consumes that. So it is basically a pub/sub model or a stream model. Both models are being used under the async communication. Next is that external communication where we are connecting with the third parties and external world. In this sync communication generally happens onto the HTTP protocol or TCP protocol. Async communication also happens using the executors or in-memory database. Nowadays, async communication happens using the binary protocol also. So we will learn later in subsequent sessions. When we talk about sync communication, it generally happens onto the HTTP protocol. So here we are going to focus onto the HTTP 1.1 protocol and 2.0 protocol. So 1.1 protocol is REST over JSON, XML or SOAP or some custom protocols. Whereas HTTP2 protocol is using generally a binary GRPC protocol. In the async communication, we use messaging protocol like Kafka messaging, Redis, AMPQ, and database store, async executor, protocol buffers, GRPC messaging, unidirectional or bidirectional, and also we use that unary method. Now let us understand some difference between gRPC versus REST. As we discussed that REST is working on 1.1 protocol, gRPC is working on 2.0 protocol. Both supports the cross platforms. It has a message format like JSON, XML and custom, whereas gRPC works onto the protocol buffer. REST has medium to large payload, whereas protocol buffer or a gRPC has a small payload. Since JSON, XML or any custom message format always goes for the serialization and deserialization, whereas that since protocol buffer is a binary, so it is a strong type message, and latency in the JSON is very high, whereas on gRPC it is low. Browser support is more widely onto the REST, whereas gRPC is require a specific browser web. Code complexity is high on gRPC. It takes approximately 2 to 3 hours, whereas that REST can be learned in 30 minutes with the basic coding and can be applied. In the modern applications, most of the persons or most of the companies are going on to the REST, but nowadays gRPC is also picking up when it requires a faster communication and throughput is high. In one of the tests which I have done, which I am going to show you next, where you will see that approximately 5 to 6 times faster is the gRPC, and network load is also very less. So network load we will not see over here, but we are going to see onto the performance of gRPC versus REST. So let us see onto the live application. So if I look onto the applications, here is the application. Let me increase the font. So I have created two applications. One is that server, another is a client application. So let us first understand the POM, that what all things are there. So I have used that Spring startup project where I chose 2.7.2 version because 3.0.1 has some limitations. I was not able to configure the gRPC properly. So I took 2.7.2 and then certain dependencies I have added. First dependency is major that netty. These netty is a server which is going to invoke that gRPC calls. Then we have gRPC stub, gRPC protocol buffer, then annotations. On top of that, it has a Maven extension, and this Maven extension is krmod.d.maven, and this is Maven plugin. I am using 1.6.2. Also, you need to add that what is the artifacts, proto-C artifact plugins, and you can specify the path also, that how it is going to be, where it is going to be, and also the goals. I have kept the protocol buffer onto the signature file on my main folder. If you look, it is parallel to a main and protocol buffer. Here I have that hello.proto. When we talk about the syntax or signature of this protocol buffer, it has syntax like it is using protocol 3 version. Also, I gave that what is the package name. After the package, I'm going to have message request is going to be a first name and last name. Response is going to be a greeting response, and then I'm going to have a service. This service is being created by the system itself. It has a different type of you can say different type of variables we can define, string, integer. So it has a specific types I will discuss in subsequent sessions that what all different types are there, how it can be defined. But on a high level, this is the protocol buffer file. So what we need to do, we need to go and do the Maven compile. Once we do the Maven compile, it is going to create the files. It will generate certain source, and this source is going to be set onto your classes. And these source is basically protocol buffer. You see here that Java, it has a service. So it is a request, the one which we have created. This is a response, and this is a hello world as a service. So this service is your major service. Hello response and hello builder service. These two are the services which has been created. Now we are going to extend these services with our custom services. I'm going to close all the tabs. So this is a gRPC service which has been created. In this gRPC service, I have extended this to a hello service implementation base, and here I have taken the request, response, and done the observer, created the observer. Over here, what I did, appended as a string builder and calling that builder, passing this and sending back. And after that, we are completing this request. Similarly, onto the REST service, very same thing. I have created a method. This method is creating a string using the string builder of the same with the DTU and returning the greeting as a string. And after that, I have created the one REST controller. This REST controller is going to provide that connect with the outside world for processing. So this is the server is ready. We can launch this server and move ahead. Similarly, we go onto the client, same POM, not much of the difference, except that I have added the Fiend over here. This Fiend client is basically communicate to the Java to Java as a microservice. So I have created Hello application client. This client is a Fiend client where REST client I have added with the local host 8081, and I am passing this hello post request to the server. After that, I have that controller which I am going to call from the local application. Over here, you can see that hello REST, it is, I am passing this and iterating this for n number of times that how my response is going, and I'm incrementing with 1. Similarly, I have a gRPC controller. This is going to invoke the gRPC client service. So what is the gRPC client service? Here I am creating a channel which I'm starting onto the server with 8085 port using that channel builder. And after that, I am processing all those requests to a hello response using the gRPC, and at the end I'm printing that how much time it has taken. So my both the applications are ready. I cannot run on these applications onto this system because once I do this, it is making the system slow. So I'm passing this onto the AWS server. So let me take you guys to AWS server. So here is my AWS server which I am going to run. So I'm going to connect the AWS server. This is my AWS server connected. Now I will show you I have compiled version, the jar file which I have created. I uploaded over here the 2 gRPC client files. You can see, and I have started these things. So if I show you, you can see that This is a server running and this is a client running. Now I'm going to pass that both the request which we have created. Curl http colon slash slash localhost colon 8080 slash hello. First, let us go on to the GRPC. GRPC, and I'm going to pass 100,000 requests. Let us see how much time it takes to process the 100,000 request. So it has started. Once it finishes, it will give the prompt back and we will see that how much time it took. It is generally going to take approximately 30 seconds or 35 seconds maximum, but in general it takes approximately between 20 to 30 seconds. So it has processed. Let us see that how much time it took. So you can see that it took approximately 30 seconds. This time is in millisecond, so it is a 30 second it took. Let us go and run the same thing with the REST client, that how much time it is going to take onto the REST. Same request, same number of requests I am going to send over here. This request is sometimes takes approximately 150 to 160 seconds. So you need to be patient for 2 minutes. Meanwhile, I will update you that there are certain nuances onto the gRPC. Those nuances I'm going to discuss in some of the other lectures. But in this, I have given that basic idea that why we can choose gRPC. You need to decide which one is good for you, but always that gRPC is going to be a faster on over the REST endpoints. It has a certain limitations like user must have that skilled team or you can train them. So if you have a good team, you want to go and your application permits, your application requires, then use a gRPC, which is a better protocol. And it will also give you two benefits. One is that performance. Second, your network bandwidth will also reduce, which will give a better impact on your processing. So it is still working. Approximately 150 to 160 seconds it is going to take. You can see still it is processing. Okay, let us see on to, yeah, so it has processed. Let us see that how much time it took. So you can see here 146 seconds it took. So approximately 5 times is more time is taken by the REST controller, whereas the our GRPC controller is taking lesser time, approximately 30 seconds. So 30 seconds versus 146 seconds or 150 seconds, 5 times. Now you have to choose that how it is going to be affecting your applications and what you want to use. So this is all on this session. I would say that keep experimenting, better performing, and do experiments on the gRPC and REST endpoints. If you need anything or any suggestions or any information, you can message me or you can put onto the comments. Whenever I'll get the time, I will reply you guys that what we can use. Thank you.